So today's lesson is reasoning about radical and rational equations. So we are just going to walk through the steps and kind of discuss the properties that we use to solve radical and rational equations. So we know that when we sometimes square both sides of an equation, we end up with what's called extraneous roots. And it happens because typically when we square something that is negative, we end up with a positive. And so sometimes as we manipulate that algebraically, we end up with a solution that actually doesn't work in the original equation. So that solution is called an extraneous root. Well, before we start solving these radical and rational equations, we want to talk about the properties that allow us to do this. So our first property that we're going to talk about is the addition property of equality. And that says that if A equals B and C equals D, then A plus C equals B plus D. Meaning if you have two equal quantities and you add to that two other quantities that are equal, then you're going to get a true statement. The multiplication property is the same. If A equals B and C equals D, then A times C equals B times D. So we're going to use those two properties and kind of identify our steps. So in our first example, we have the equation x equals the square root of x plus 6. So you know that in order to get rid of that radical symbol, you have to square both sides. Well, since x equals x plus 6, think of this as a equals b. Well, we know that I can also say that x is c and the square root of x plus 6 is d. So I can take a times c and set it equal to b times d. So this is an example of the multiplication property of equality. Okay. In our next step, once we square both sides, we end up with x squared equals x plus 6. Well, if you think about what you remember from quadratics, the only way to solve a quadratic is to set it equal to 0. So I actually have to subtract x from both sides and subtract 6 from both sides. So, or add a negative. So this is the addition property of equality. And then we get the quadratic equation x squared minus x equals 6. I know that this factors into a negative 3 and a positive 2. Negative 3 times 2 gives me negative 6. Negative 3 plus 2 gives me negative 1. So my factors are x minus 3 and x plus 2. Well, if x minus 3 equals 0, then x equals 3. And if x plus 2 equals 0, then x equals negative 2. We learned this in Math 1 when we started solving equations that were quadratic. And so this is just the zero product property. All right. So we're going to take what we know about these two solutions, x equals 3 and x equals negative 2, and we're going to check to see if they're extraneous. So when we do that, we have to substitute it into the original equation. We're substituting it into the original equation. So the first thing that we're going to do is we're going to let x equal 3. So 3 equals the square root of 3 plus 6. Well, 3 plus 6 is 9, and the square root of 9 is in fact 3. So 3 does equal 3. 3 is a good root. Now let's check x equals negative 2. So if I let x equal negative 2 equals the square root of negative 2 plus 6. Negative 2 equals, let's see, the square root of negative 2 plus 6 is 4, and the square root of 4 is 2. Negative 2 does not equal 2. So this solution, this root, is extraneous. So it means it's not a solution. It does not work. Extraneous roots get introduced because of operations. The operation of squaring is irreversible, meaning that once we've squared, we can't know the original quantity. For example, if we square a -2, it equals a +4. So its root could be a positive or a negative. So let's take a look at another example. So it says, consider the relatively easy equation -2x = 6. Solve this equation by using the reversible operation of division. So if I wanted to solve -2x = 6, I would divide both sides by -2, and I find out that x equals -3, and that's because division is reversible. Now let's look at our second example, and we're going to solve the equation by squaring both sides first. We're going to solve the equation by squaring both sides first. So -2x, the quantity squared, equals 6, the quantity squared. Well, let's see. -2 times -2 is 4, and x times x is is x squared. So I end up with 4x squared equals 6 squared is 36. When I divide both sides by 4, I find out that x equals 9. So we see, hopefully, that the operation of squaring is not reversible. That's all this is trying to show you, is that the operation of squaring is not reversible. It's called irreversible. So when you square, you sometimes get extraneous roots. So in the case of solving square root equations, because we square both sides at some point to remove the radical, we sometimes introduce solutions that do not make our original equation true. Let's investigate why it happens sometimes with rational equations. So consider the rational equation x divided by x minus 1 equals 2x plus 6 over x plus 3. So some of you I know are already thinking ahead, and you know that you can, and maybe you're not, but I'm pretty sure that you are. You know that you can take a 2 out of this numerator, and you end up with 2 times the quantity x plus 3. And we've done so much work with this that you know you're going to end up with 2 over 1. We're going to be able to simplify that, right? Well, remember we talked about eliminating the denominator. We're trying to eliminate the denominator. So you see that I multiply both sides by the quantity of x minus 1 and x plus 3. Well, this is the multiplication property of equality. My x minus 1s cancel out, so I'm left with x plus 3 times x, which is pictured right here. When I multiply the right side of my equation, my x plus 3's cancel out, so I'm left with x minus 1 times the quantity of 2x plus 6. So I do some foiling, and when I FOIL, I get x squared plus 3x equals 2x squared plus 4x minus 6. I know that I have to set my quadratic equal to 0, so I'm going to go ahead and subtract x squared from both sides and subtract 3x. So I get 0 equals x squared plus x minus 6. Well, subtracting the same amount or adding a negative is the addition property of equality. The addition property of equality. Lastly, I have my two factors, x plus 3 and x minus 2. I set them equal to 0 and solve for my roots. Remember, when you set your factors equal to 0 and solve, this is the 0 product property. So which of the two solutions in this equation are extraneous? Well, let's see. If I have x over x minus 1 equals 2x plus 6 over x plus 3, the first root that I'm going to check is x equals -3. So I'm going to plug in a -3 for x. So I have -3 over -3 minus 1 equals, let's see, 2 times -3 is, well, let me put a 2 out there. 2 times -3 plus 6 equals negative 3 plus 3. When I simplify, let's see, I end up with negative 3 over negative 4 equals 2 times negative 3 is negative 6, and negative 6 plus 6 is 0 over 0. And 0 divided by 0 is 0. And we know that negative 3 over negative 4 does not equal 0. All right. So the extraneous root is arising because multiplying both sides of the equation by anything containing a variable, like the factors x minus 1 or x plus 3, is irreversible. Because again, we don't know what the value of x is, and you could essentially be multiplying both sides by 0. So we're going to look at this equation, 5x equals 15, and we know the solution is x equals 3. We're going to solve this equation by multiplying both sides of the equation first by x minus 1. So let's see, I have 5x equals 15. I want to multiply both sides by x minus 1. I want to multiply both sides by x minus 1. So 5x times x is 5x squared, and 5x times negative 1 is negative 5x. Equals, well, 15 times x is 15x, and 15 times negative 1 is negative 15. I am going to subtract 15x and add 15 to both sides. So subtract 15x and add 15. So I can set it equal to 0. And when I do that, I end up with 5x squared minus 20x plus 15 equals 0. First of all, I can take a 5 out of this, and that leaves me with x squared minus 4x plus 3 equals 0. And when I factor this, I get x minus 3 times the quantity of x minus 1 equals 0, which means that x equals 3 and that x equals 1. So I have to plug it back in and check. Plugging it into the original equation. 5 times 1 equals 15. Well, we know that 5 times 1, because remember this was our original 5x equals 15. We know that 5 times 1 is 5, and 5 does not equal 15. So x equals 1 is extraneous. So this activity is just really a lesson showing you why extraneous roots are formed and how it's formed, okay? So your homework is 2 through 5, questions 2 through 5. So I told you I would do some of these with you. I'm going to do number 1 with you because it's not part of your homework, and I want you to see what happens. So the first thing that I'm going to do is divide both sides by negative 1. And I'm going to do that because I want to get rid of that negative outside of my radical. So I really have negative x equals the square root of 3x plus 10. Now I'm going to square both sides. Negative x times negative x is positive x squared. X squared equals 3x plus 10. I then subtract 3x and 10 from both sides, and that leaves me with x squared minus 3x minus 10 equals 0. This factors out to x minus 5 times x plus 2 equals 0. Well, that means that x equals 5 or that x equals negative 2. So let's check and see if we have any extraneous solutions. So I'm going to substitute in first the 5 into the original equation. 5 equals negative the square root of 3 times 5 plus 10. Well, 3 times 5 is 10. Sorry, 3 times 5 is 15, plus 10 is 25. So 5 equals the opposite of the square root of 25. Well, the square root of 25 is 5, and 5 does not equal the opposite of that, which is negative 5. So 5 is an extraneous solution. Let's check negative 2. If I let x equal negative 2, I have negative 2 equals the opposite of 3 times negative 2 plus 10. Well, 3 times negative 2 is negative 6, and negative 6 plus 10 is 4. So I have negative 2 equals negative the square root of 4. Well, the square root of 4 is 2, so I have the opposite of 2 equals negative 2. And this is true. So this solution is good. So you are going to do 2 and 3, 4 and 5. So squaring both sides of an equation is irreversible. This is number 6. Is cubing both sides of an equation reversible? Provide numerical examples to help support your answer. We will do this on Tuesday. This will be our warm-up. Okay. I want you guys to be excellent for the sub. Please make sure to complete your homework. Remember that I'm checking your notes on Tuesday, and I hope that you guys had a great weekend. Thank you.